Question 1. In the context of a commercial HVACR installation utilizing lithium-ion battery storage, Mr. Salazar notices irregular voltage fluctuations between cells during routine diagnostics. He considers bypassing the battery management system (BMS) to maintain HVAC operation temporarily during a peak cooling period. What should Mr. Salazar do? A. Proceed with bypassing the BMS if cell temperature remains within the safe range. B. Manually equalize the cells using a voltage regulator. C. Immediately shut down the battery system and investigate the BMS. D. Allow the BMS to continue its self-correction cycle before taking action. Answer. Correct answer. C. Immediately shut down the battery system and investigate the BMS. Explanation. Bypassing the BMS is extremely hazardous. The BMS ensures cell balancing, overcharge-discharge protection, and thermal safety. Irregular voltages may indicate cell degradation, thermal runaway risk, or system fault. OSHA 29 CFR 1910.137 and NFPA 855 require the use of protective systems and prohibit tampering. ANSA Canal 1973 also outlines critical safety operations that rely on the BMS. Operation without it compromises fire and explosion safety. Question 2. While examining a chilled beam system integrated with a best thermal energy storage, a technician notices the room fails to maintain its designed thermal comfort. What is the most probable underlying cause? A. The PCM failed to undo a complete phase transition due to incorrect temperature set points. B. The chilled beam system is too small for the building load. C. The airflow rate is too low for the PCM storage to operate efficiently. D. There is inadequate humidity control in the occupied space. Answer. Correct answer. A. PCM failed to undo a complete phase transition due to incorrect temperature set points. Explanation. PCMs rely on narrow phase change temperature ranges to store and release latent heat. Improper set points result in incomplete melting, freezing, reducing capacity. ASHRAE Handbook HVAC Systems and Equipment, Chapter 51 outlines performance optimization for PCMs. Unlike airflow or humidity, thermal performance here hinges on correctly leveraging the PCM transition, not mechanical size or humidity alone. Question 3. Based on the information from a discharge log of a lithium iron phosphate LiFePO battery bank supporting a EST system, it is observed that the batteries consistently reach a 100% discharge state. What is the long-term implication of this practice? A. Improved overall energy output due to full utilization. B. Increased system efficiency due to deeper cycling. C. Accelerated battery degradation and reduced life cycle. D. Enhance BMS performance through learning algorithms. Answer. Correct answer. C. Accelerated battery degradation and reduced life cycle. Explanation. Repeated 100% depth of discharge DOD significantly shortens battery life. LiFePO chemistry tolerates moderate DOD but full discharge stresses electrodes, reducing cycle count. EST 1679.1 and manufacturer specs recommend shallower cycles to extend life. BMS does not benefit from this. Instead, it may trigger protective shutdowns. Efficiency doesn't increase with deeper cycles. Question 4. Given the circumstances, Isa Patel is designing a hybrid HVACR system using both thermal storage and battery backup. The facility operates heavy chillers at night. What is the most important design consideration when calculating the sizing of the battery system? A. The maximum voltage rating of the chillers. B. The average daily outdoor ambient temperature. C. The peak electrical load during transition from storage to grid. D. The battery manufacturer's calendar life guarantee. Answer. Correct answer. C. The peak electrical load during transition from storage to grid. Explanation. Battery systems must support the peak transition load, not just average demand. Sizing to handle transient surges avoids brownouts or controller faults. ESTD 1013 and NFPA 70 NEC Article 706 Stress Load Profile Analysis. Voltage rating is not the sizing basis, and ambient temperature affects capacity, not load directly. Calendar life is secondary in system design. Question 5. As demonstrated by Mr. Douglas integrating energy storage with a supermarket's HVACR and refrigeration system, the client demands reduced peak demand charges. Which integration strategy would provide the most efficient use of storage? A. Use storage solely during power outages. B. Uh, 1. The HVAC directly from the grid and bypass storage. C. Shift HVAC loads to off-peak hours using storage discharge. D. Discharge the battery system continuously regardless of load profile. Answer. Correct answer. C. Shift HVAC loads to off-peak hours using storage discharge. Explanation. Load shifting aligns HVAC operation with off-peak electricity rates using stored energy, reducing demand charges. This is a key benefit of energy storage in commercial HVAC dose. Energy Storage Technology and Cost Characterization Report of 2020 and ASHRAE guidelines promote such time of use strategies. Continuous discharge is inefficient and outage-only use misses economic benefits. Question 6. In the event of a thermal runaway incident in a battery room adjacent to HVAC mechanical systems, what is the technician's immediate priority under NFPA and OSHA guidelines? A. Disconnect the HVAC systems to isolate heat sources. B. Activate the HVAC system to increase air dilution. C. Ventilate the room manually using industrial fans. D. Evacuate personnel and initiate fire suppression systems. Answer. Correct answer. D. Evacuate personnel and initiate fire suppression systems. Explanation. Thermal runaway in lithium-ion systems can lead to explosive gas release and fire. NFPA 855 and OSHA 29 CFR 1910.38 require immediate evacuation and use of automated suppression. Manual intervention risks exposure to toxic gases and flame. HVAC systems must be shut down remotely. Manual fan use is unsafe. Isolation is secondary to life safety. Question 7. To illustrate this point, HRConquer attempts to integrate a modern lithium battery storage system with an older HVAC panel lacking smart controls. What is the most significant integration risk? A. Loss of energy storage warranty due to legacy equipment. B. Excessive energy efficiency due to system mismatches. C. Incompatibility with automated demand response protocols. D. Frequent HVAC compressor cycling due to overvoltage. Answer. Correct answer. C. Incompatibility with automated demand response protocols. Explanation. Leggy HVAC systems may lack communication protocols like BACNetIP or OpenADA, preventing effective demand response integration. This limits dynamic control of energy discharge, reducing ROI. And ASHRAE Standard 135 and California Title 24 highlight the role of interoperable controls. Warranty and efficiency issues are possible, but protocol mismatch is the core issue. Question 8. A critical examination of preventative maintenance logs reveals a consistent oversight in inspecting battery terminal torque in an HVAC energy storage system. What consequence is most likely to result from this omission? A. Decreased battery runtime due to electrochemical inefficiency. B. Fire hazard due to increased contact resistance and heat. C. Corrosion of terminals due to air exposure. D. Shortened inverter life due to frequency harmonics. Answer. Correct answer. B. Fire hazard due to increased contact resistance and heat. Explanation. Loose terminals create high-resistance joints that generate heat under load, increasing fire risk. NFPA 7-tip and EST 450-2020 emphasize torque inspection as critical. Thermal imaging can detect this early. Corrosion is more related to humidity and leakage. Harmonics don't directly result from torque faults. Question 9. Through careful analysis of a hospital's ice storage system, technicians find the ice is melting prematurely before morning HVAC load peaks. Which of the following is the most plausible explanation? A. Improper insulation of the ice tank causing heat gain overnight. B. The chiller is operating below rated capacity. C. The supply air temperature is too low for patient comfort. D. There is insufficient glycol concentration in the loop. Answer. Correct answer. A. Improper insulation of the ice tank causing heat gain overnight. Explanation. Heat ingress into the tank prematurely melts ice, reducing availability during critical peak periods. ASHRAE recommends insulation R values tailored to ambient conditions. Chiller capacity or air temperature would not cause premature melt. Glycol affects freeze point, but not melt timing once ice is formed. Question 10. With respect to NEC Article 706, which of the following is a required safety consideration when installing battery wiring for energy storage systems in HVAC applications? A. Neutral conductors may be shared across battery banks. B. All conductors must be color-coded red for positive and black for negative. C. Conduit is optional if cables are double insulated. D. Overcurrent protection must be installed as close as possible to the battery terminals. Answer. Correct answer. D. Overcurrent protection must be installed as close as possible to the battery terminals. Explanation. NEC Article 706.30 mandates overcurrent devices within specified distances of terminals to prevent high fault currents. Shared neutrals are not allowed. Color coding must follow standard NEC conventions, not arbitrary schemes. Conduit requirements are separate from insulation ratings. Question 11. From a practical standpoint, EST Coleman is disposing of multiple damaged lithium-ion battery modules removed from an old HVACR energy storage system. The facility lacks a dedicated hazardous materials disposal station. Which of the following is the most appropriate action according to OSHA and EPA guidance? A. Store the batteries in plastic bins in a locked HVAC mechanical room. B. Submerge the batteries in sand and transport to the local landfill. C. Isolate the batteries in a climate hazardous material container and contact a certified waste disposal vendor. D. Mix the damaged modules with intact ones in the original shipping crate and label as scrap. Answer. Correct answer. C. Isolate the batteries in a climate hazardous material container and contact a certified waste disposal vendor. Explanation. OSHA 29 CFR 1910 Subpart H and the EPA's Universal Waste Rule 40 CFR Part 273 mandate strict handling and disposal protocols for lithium-ion batteries due to fire, chemical, and environmental risks. Damaged batteries must be stored in fire-labeled containers and disposed through certified vendors. Improper storage or landfill dumping can result in fines and liability. Question 12. Taking into account that IS Vargas manages a large HVACR integrated thermal and battery energy storage system for a data center, she observes performance drift during peak hours over several months. Which diagnostic method provides the most reliable long-term assessment of system performance degradation? A. Manual inspection of wiring and terminal points weekly. B. Monitoring voltage and temperature readings once a month. C. Utilizing continuous SCADA or EMS-based trend analysis for system outputs and efficiency. D. Relying on user complaints about inconsistent cooling levels. Answer. Correct answer. C. Utilizing continuous SCADA or EMS-based trend analysis for system outputs and efficiency. Explanation. Supervisory control and data acquisition SCADA and energy management systems EMS offer high resolution continuous monitoring of energy metrics over time, which is critical in identifying efficiency loss, control loop degradation, or load mismanagement. ASHRAE Guideline 22 and E1491 support data-driven trend analytics for root cause diagnosis over manual or reactive methods. Question 13. The primary reason for selecting lithium iron phosphate LiFePO over lithium cobalt oxide LiCu in HVACR applications with rooftop solar integration is A. Higher energy density and lower cost of LiFePO. B. LiFePO is lighter and better suited for mobile HVAC systems. C. LiFePO offers superior thermal stability and cycle life under high temperature conditions. D. LiCu supports deeper discharges than LiFePO. Answer. Correct answer. C. LiFePO offers superior thermal stability and cycle life under high temperature conditions. Explanation. LiFePO is known for exceptional thermal stability, low risk of thermal runaway, and longer cycle life. Critical for HVACR systems exposed to outdoor or rooftop heat, it tolerates abuse better than LiCu, which has higher energy density but greater safety risks. As Powell 1973 and manufacturer, LiFePO is ideal for stationary HVAC-related applications with temperature variability. Question 14. By evaluating a district cooling plant's performance, Istabel finds that the ice storage system is not maintaining reserve energy for peak hour HVACR use. What system design flaw is most likely the root cause? A. Oversized heat exchangers allow excessive melt rates. B. The control logic is using fixed temperature schedules rather than demand forecasting. C. The water circulation loop uses stainless steel instead of PVC. D. The return water temperature is too low to trigger ice charging. Answer. Correct answer. B. The control logic is using fixed temperature schedules rather than demand forecasting. Explanation. Fixed schedules ignore real-time demand spikes leading to premature energy depletion. Advanced test systems require predictive control algorithms based on weather, occupancy, and utility pricing. ASHRAE Guideline 36 supports demand-based controls to optimize ice usage. Pipe material and exchanger size are secondary to operational strategy in energy reserve retention. Question 15. With the advent of high-capacity energy storage for HVACR, NASA must install a battery bank in a confined space. Which of the following safety practices is mandated by NFPA and OSHA? A. Ventilate the room manually after battery charge cycles. B. Allow class of fire extinguishers for battery-related events. C. Use explosion-proof ventilation and hydrogen sensors if batteries emit gases. D. Permit open flame heating during winter operations to maintain battery temperature. Answer. Correct answer. C. Use explosion-proof ventilation and hydrogen sensors if batteries emit gases. Explanation. OSHA 29 CFR 1910.178 in an FPA 7 tie require battery rooms with potential gas emissions e.g. lead acid to include explosion-proof ventilation and hydrogen detection to prevent accumulation and ignition. Class D extinguishers are needed for battery fires, not Class A. Open flames are strictly prohibited in battery rooms. Question 16. During the process of auditing a mixed-use building, Yamada is tasked with analyzing the HVACR load to size a hybrid energy storage system. What key factor must be prioritized to ensure accurate load analysis? A. Only the connected load of HVAC equipment. B. The nameplate voltage of all motors and fans. C. The demand load based on time of use, cycling, and diversity factors. D. The standby losses of battery inverters. Answer. Correct answer. C. The demand load based on time of use, cycling, and diversity factors. Explanation. Demand load reflects real-world usage patterns including time of use rates, coincident peaks, and equipment cycling. NEC Article 220 and ASHRAE Fundamentals stress using demand load over connected load for storage sizing. Nameplate data overestimates needs while inverter losses are minor relative to HVAC demand. Question 17. Historically speaking, a company removes a 15-year-old thermal energy storage system integrated with a central chiller plant. What is the most compliant and environmentally responsible action during decommissioning? A. Flush the tank contents into the storm drain. B. Sell all components for scrap metal value. C. Recover and recycle all fluids and refrigerants, then dismantle under local environmental codes. D. Leave the system in place and disconnect it from power. Answer. Correct answer. C. Recover and recycle all fluids and refrigerants, then dismantle under local environmental codes. Explanation. EPA Section 608 and OSHA 29 CFR 1910.147 require proper refrigerant recovery and handling of glycol or brine solutions as hazardous waste if applicable. Local codes often prohibit uncontrolled discharge. Simply disconnecting violates decommissioning practices and environmental regulations. Question 18. The effectiveness of thermal energy storage integration into HVAC depends heavily on its control logic. Which control strategy is best suited to optimize energy use during both peak and off-peak periods? A. Night-only discharge mode. B. Manual override by facility managers. C. Predictive model-based control using real-time weather and occupancy data. D. Fixed interval operation based on daily time clock. Answer. Correct answer. C. Predictive model-based control using real-time weather and occupancy data. Explanation. Model predictive controls, MPC dynamically optimize test operation based on external variables, improving efficiency and cost savings. ASHRAE 2023 research supports MPCS over fixed-time strategies. Manual overrides reduce reliability. Whether integration aligns with utility demand charges and actual cooling needs. Question 19. Examining the consequences of a repeated system fault in an HVACR battery backup system, Ortega identifies fluctuating inverter output voltage during early morning startup. Which troubleshooting approach should be used first? A. Replace the inverter with a higher capacity model. B. Inspect the battery string for voltage imbalance or aging cells. C. Adjust the HVAC startup schedule to a later time. D. Modify the charge controller set point for a faster ramp up. Answer. Correct answer. B. Inspect the battery string for voltage imbalance or aging cells. Explanation. Uneven battery performance causes unstable inverter outputs, especially under surge loads like HVAC startups. EST 1188 and NFPA 7 recommend regular cell-level diagnostics. Changing HVAC schedules or upgrading inverters won't fix the root cause. Charge controller modifications may worsen imbalance. Question 20. From multiple perspectives, communicating with facility owners about the ROI of energy storage can be challenging. What key concepts should the technician emphasize when explaining HVACR integrated storage benefits? A. Reduced capital expenditure of installing large compressors. B. Minimizing energy use during the highest cost utility periods through load shifting. C. Improved indoor air quality due to thermal mass control. D. Faster HVAC system response time during occupancy transitions. Answer. Correct answer. B. Minimizing energy use during the highest cost utility periods through load shifting. Explanation. HVACR integrated energy storage is primarily adopted for economic benefits via peak shaving and demand charge reduction. Doe and ASHRAE emphasize this in life cycle analyses. While IAC and fast response are benefits, they are secondary. Capital costs of compressors are unrelated to storage unless explicitly redesigned. Question 21. In response to an office building's plan to run HVAC systems on battery power during brownouts, Mr. Daniels calculates the battery requirements. He mistakenly uses only the nameplate ratings of HVAC equipment in his load analysis. What is the most likely consequence of this error? A. The system will be oversized and operate inefficiently. B. The inverter will fail due to surge current overload. C. The batteries will be undersized and deplete prematurely. D. The control system will not synchronize with the grid. Answer. Correct answer. C. The batteries will be undersized and deplete prematurely. Explanation. Nameplate ratings reflect theoretical max load, but HVAC systems often draw higher current at startup or during transient loads. Ignoring peak demand, the surge factors, or load diversity leads to undersizing. NEC Article 220 and ESTD 1013 emphasize demand-based sizing to ensure reserve during peak conditions. Inverter or failure may follow, but is not the root error. Question 22. Throughout the course of a system retrofit, Ziegler must select a power conversion system (PCS) to bridge battery storage with HVACR controls. Which PCS feature is most critical for compatibility with modern variable speed HVAC systems? A. Fixed frequency output and manual control interface. B. Transformerless designed to reduce harmonic distortion. C. High frequency output and fast response time. D. Oversized casing for improved cooling in hot climates. Answer. Correct answer. C. High frequency output and fast response time. Explanation. Variable speed HVAC systems require precise voltage and frequency matching, especially under dynamic loads. High frequency pulse width modulation PWM ensures stable inverter output. E519 and ASHRAE recommend harmonic mitigation and fast dynamic response to maintain compatibility. Casing or transformer design matters less in this context. Question 23. As evidenced by regular temperature delivery in a thermal storage coil, Mr. Alvarez suspects a malfunction in the heat exchanger. Which symptom best supports this diagnosis? A. High humidity levels in condition zones. B. Chiller cycling erratically during off-peak hours. C. Large temperature delta between inlet and outlet with low thermal output. D. Fan coil units failing to respond to occupancy sensors. Answer. Correct answer. C. Large temperature delta between inlet and outlet with low thermal output. Explanation. An excessive temperature difference with minimal heat transfer suggests fouling or flow restriction in the exchanger. ASHRAE 2020 Fundamentals highlights proper delta T management as a key indicator of exchanger performance. Humidity or sensor issues may point to other subsystems. Chiller cycling may be unrelated unless load mismatch exists. Question 24. During the process of inspecting an energy storage installation, Istacoli notices that the battery conductors pass through a shared conduit with lighting circuits. According to NEC Article 300 and 706, what is the compliance risk? A. The system may be overloaded due to cumulative voltage drop. B. Electromagnetic interference could damage HVAC thermostats. C. Mixing Class 1 and Class 2 wiring in a single raceway may violate code. D. The conduit fill percentage exceeds thermal dissipation limits. Answer. Correct answer. C. Mixing Class 1 and Class 2 wiring in a single raceway may violate code. Explanation. NEC Article 300.3c prohibits combining Class 1 power and Class 2 control signal conductors in a single raceway unless insulation, voltage rating, and system type are specifically addressed. This protects against cross-interference and fire hazards. ME and voltage drop are concerns but not the primary compliance issue. Question 25. Among the various strategies to improve chiller load reduction via thermal energy storage is Santiago proposes a floating setpoint control method. What is the primary advantage of this strategy? A. It allows for complete disconnection from the grid during off-peak hours. B. It maintains indoor humidity control regardless of external conditions. C. It enables test systems to respond dynamically to real-time grid pricing. D. It reduces wear on storage tanks by lowering temperature cycling frequency. Answer. Correct answer. C. It enables test systems to respond dynamically to real-time grid pricing. Explanation. Floating setpoint control adjusts charging and discharging thresholds based on grid signals, reducing peak demand charges. ASHRAE Guideline 36 and DOSMART grid standards encourage dynamic control tied to energy tariffs. It does not impact tank wear directly, nor does it ensure humidity control or full grid disconnection. Question 26. The underlying principle of effective HVACR energy storage is managing the battery's charge-discharge profile. Which of the following practices will most likely extend lithium-ion battery lifespan in HVACR applications? A. Full charge to 100% and full discharge daily. B. Shallow charge-discharge cycles within 2080% SOC range. C. Disabling temperature-based BMS protection during winter. D. Using fast charging at double the manufacturer's C rate. Answer. Correct answer. B. Shallow charge-discharge cycles within 2080% SOC range. Explanation. Maintaining state of charge SOC between 20%–80% significantly improves cycle life and minimizes electrode stress. The STD 1679.1 and IL 1973 support mid-range operation for long-term stability. Full cycling fast charging or BMS override accelerates aging and may trigger warranty violations or safety events. Question 27. To determine whether an energy storage technician should re-enter a battery room after a suspected thermal event, which safety metric is most critical? A. The voltage drop across individual cells. B. The ambient room temperature. C. The hydrogen gas concentration level. D. The power status of the inverters. Answer. Correct answer. C. The hydrogen gas concentration level. Explanation. Hydrogen buildup poses an explosion hazard following thermal runaway or venting. NFPA 855 and OSHA 20I and CFR 1910.146 mandate safe atmospheric conditions, hydrogen 1% by volume before re-entry. Voltage or inverter status is secondary if atmospheric hazards remain. Temperature is not a reliable sole indicator of gas presence. Question 20. Considering the evidence, Mr. Lindstrom is evaluating an HVAC system with an integrated battery bank for a remote cold storage warehouse. What unique challenge must be addressed for optimal performance? A. Battery overheating due to poor ventilation. B. Reduced inverter efficiency in low humidity environments. C. Loss of battery capacity in sub-zero temperatures. D. Sudden spikes in grid voltage from backup generators. Answer. Correct answer. C. Loss of battery capacity in sub-zero temperatures. Explanation. Lithium-ion and lead-acid batteries experience reduced chemical activity at low temps, leading to diminished capacity and power output. E1184 and battery manufacturer data recommends thermal conditioning or insulation for cold climates. Overheating is unlikely in sub-zero storage. Inverter and generator effects are minor compared to cold-induced degradation. Question 29. In the absence of obvious physical damage, is De Morgan suspects internal degradation in an HVACR battery bank that's underperforming? Which of the following diagnostic tools provides the most accurate internal condition assessment? A. Thermal imaging to detect hotspots. B. Mega testing of conductors. C. Electrochemical impedance spectroscopy eyes. D. Voltage drop test under no-load conditions. Answer. Correct answer. C. Electrochemical impedance spectroscopy eyes. Explanation. EYES identifies internal resistance, aging, and capacity fade with high precision by analyzing frequency response. E1491 recommends EYES for advanced diagnostics. Thermal imaging detects surface faults, not internal chemistry. Mega testing is for insulation, not batteries. No-load voltage tests are too basic to assess degradation. Question 30. Focusing specifically on integrating solar HVAC and battery storage, EST Chow identifies recurring issues with system sync during low-light mornings. Which integration feature is essential to resolve these timing mismatches? A. Overvoltage protection relay on the HVAC control board. B. Time of day-based manual override switch. C. Smart inverter with grid following and grid forming capabilities. D. Increased wire gauge to reduce morning voltage drop. Answer. Correct answer. C. Smart inverter with grid following and grid forming capabilities. Explanation. Smart inverters can form their own reference signal, grid forming, and sync to external sources. Grid following, solving instability during intermittent PV output. E1547 and IL1741 sub-define these advanced features. Relays or wiring changes don't address timing or synchronization control at the inverter level.